Hi everyone. Assuming we have been given a data that shows the location of where butterfly have been sighted for a particular day across the city of Port Harcourt. So somebody went out to do a survey and they found butterfly at such a location and locations were recorded. So the question has been posed, are these sightings, are they random or not? So in order to answer that question, we can use the nearest neighbor analysis or the average nearest neighbor analysis. So the tool is available within our toolbox. But before we can go ahead and do that, we must first of all project our data. So we must take it from the geographical coordinate system that it is and take it to the projected coordinate system. So transferring it from the geoid to the projected flat surface. So you can see our data is in the geographical coordinate system. So we need to project it. So let's do that. We go to search and we go project. So remember, whenever you want to do spatial analysis, especially in terms of looking for patterns and examining patterns, you need to, if you are looking, if you are computing distribution, that may not be necessary, but whenever you are looking at pattern, you need to project it in. So let's start for the projection tool. So I have project data tool in the data management toolbox. So I take my data and then I turn it to projected data set butterfly. So I give it a name, I'm saving it in the view database on the system. I select the coordinate system of interest. We want to go to UTM and we want to go to WGS. Northern 32 degrees north, that's for Nigeria. So select that, I click OK, and I have selected what I want, and then I can go ahead and say OK. So the projection will be done. It is the projected data that I will use for my subsequent analysis. So now we can come to the toolbox and click on average nearest neighbor. So we want to examine and then we want to generate the report. Okay, so we want to generate a report. So check that box, and it's usually a good thing to have the boundary of the area under consideration, but if you don't have that, that's also fine as well, but I will advise to always do that. Okay, so click OK, the analysis will take place and the result is here. So we have our result and it's saved in this file. So we can take a look at this location on our system and see what the result is. So let's find out. It's in the document, ArcGIS, I think, nearest neighbor analysis, that is today. We go in there. For it to load, so the result should tell us whether our distribution of the butterfly sighting, whether it's random or dispersed or clustered. So remember, the comparison is always made compared to whether to the random. So this is our result. So it's telling us that it is clustered. Okay, so it's our nearest neighbor ratio, is the set score, this is the p-value. The p-value here, as you can see, is less than 0.05, so which means there's a statistically significant difference. What the nearest the pattern we have found is statistically significant. So you can see the result there's less than 1% likelihood that the clustered pattern could be as a result of random chance. It means there's a process that created it. So this is how to do and how to look at the result. This is the expected distance if the event were to be random, and this is the observed mean difference from our data set. So the expected is higher than the observed. Therefore, our pattern is clustered because the distance between the events or the occurrence are shorter than it is expected. So this is the result. This is how to